Welcome back to Chris Does Rocks. As you may know, a lot of discussion online lately has been over litmus tests. That's all been political talk, but I want to discuss what an actual litmus test is in terms of science. Okay, so what I have here is litmus paper. You may be wondering, okay, but what is litmus or litmus paper? Litmus is a set of compounds extracted from lichen that were historically used as a dye. One of the important things about them is that litmus dyes are different colors depending on the acidity of the solution that they're in. Litmus paper is just filter paper, really any paper, that has been soaked in litmus so that you can apply the paper into a solution and find out how acidic it is. You tell because high acidity turns it red, low acidity or high alkalinity will turn it blue. Simple, straightforward. Also, for anybody who wants to get technical, we're using alkalinity as a proxy for base because it's generally interchangeable, not always. What I have here are tubes with prepared samples. One tap water that has been used as a control, salt water, same tap water with salt added, white vinegar in water because the smell of that much white vinegar in the lab, nobody wants to deal with you, and bleach, household hypochlorite bleach. We will take one small strip of the paper, uncap, and place it in. Give it a second to soak, and then it's done a little bit of color changing, not much. You can compare it to this nice chart on the side. According to this, we are ever so slightly acidic at 6.0, maybe a little higher. That's our tap water standard, and it's well within the standard margin for water. Idealized, perfect water that's completely pure, deionized, yada yada yada, comes in at 7.0. But any impurities will cause a shift in pH. So will things like temperature, container reactions, all kinds of things. So being off by 1, not a big deal. Now let's test the salt water. Wet. Shake off the drip. And we find it comes in at the same 6.0, which tells us the salt has not significantly changed the pH. That's to be expected because the salt will be sodium chloride that when it dissolves breaks into a positively charged sodium and a negatively charged chloride. The water will react to form a sodium hydroxide, a hydrogen chloride. Those will react back. It becomes a stable situation where nothing really changes. Let's try the vinegar. Shake off the excess and compare this one. Comes in at roughly 3.5 to 3. Put these strips out front where you can see, because that would have been clever if I thought to do it initially, but As you can see, the vinegar has produced a very decent acidic reaction. This is because vinegar is primarily an acetic acid, meaning that there's acetate ions with additional hydrogens bonded to them. When you put it in water, it frees up the additional hydrogens, and this can form either hydronium, free hydrogen, various things, also theoretically bonding hydroxides, but that's not there. Basically, it produces an acid solution. Speaking of bases, let's now get to the bleach solution. Pull off our strip, sample, shake off our excess. Shouldn't be doing this, but it's all diluted enough to be safe. And the comparison puts it somewhere between a 10 and 11. This one, again, it contains sodium hypochlorite. Sodium hypochlorite will not release hydroxide like many bases, but instead it absorbs free hydrogen from out of the water, producing an effective increase in hydroxide, a decrease in free hydrogen, thus creating a base solution. So there you go. The simple yet effective pH measuring of the litmus test.